Hey SecurityTube, welcome to part 4 of the wireless security mega primer. So before we begin, just excuse my pretty informal looks. I am terrible need of a haircut and I'm looking quite tired because it's quite late in the night here in India. But I'm all what do I say, enthusiastic about making this video. So hope you'll enjoy it. Okay, so what is going to be the objective of this video? Well, till now we've talked about the access point and the beacon frames and what they are. Now let's take it one level up and actually talk about the wireless clients and the access points talking to each other. And this is what we are going to try and strip down to the packet level using Wireshark. Okay, so demo time. Now what we've done is we've already created an access point with the SSID SecurityTube, and it's an open access point, no encryption, no nothing. That's simply because let's start with a very simple case and then kind of move up the ladder. So what we are going to do is I'm just going to use my iPhone and connect it to the access point. And while this is happening, we're going to collect packets using Wireshark to see what transaction is happening between the client and the access point. Okay, so let's begin. Let me go ahead and open up my backtrack instance. Let me jump into full screen. And here we are. Right, so we've already connected the card and created the monitor mode interface. So I request you to do that if you've not already done so. And what we'll do is let's just launch Wireshark. Right, while this is happening, kind of ensuring that my access point is up and running, and also that my Wi-Fi on my iPhone is currently switched off. Right, as you can clearly see, probably dim it a little bit. Okay, so now let us start our sniffing exercise. We are going to be on Mon 0. Before we begin this, let's go back here and ensure that actually the card is on the same channel as the access point. So how do we ensure that? Well, the first thing we can do is quickly run airmon ng to figure out, quickly run aerodump ng to figure out where the access point actually is, I mean on which channel. Now, as we can clearly see, the access point is on channel 1, right? So what we need to do is we need to ensure that the card is also currently on channel 1, right? And the sniffer interface as well. So now if we kind of look at the statistics, we will notice that the card is currently in frequency 2.412 gigahertz, which is nothing but channel 1, right? Now let's go back to Wireshark and let us start sniffing on the monitor mode interface. Right, so you see a huge deal of traffic. Let's quickly just stop for a second. What we are really interested in is packets to and from the network security tube, which is what we've created. So let's do the following. Let's ensure that at least one of the addresses is actually the access point address, right? So let's just change this filter to wlan.addr, and let's go ahead and also remove beacon frames. We are not interested in beacon frames anymore. So let's say apply and not selected, right? So this will now remove all beacon frames. So as you can now see we hardly have anything left, so let's start the sniffing once again. Now what I'm going to do is, let me quickly switch on my phone, and currently Wi-Fi, as you can clearly see on the phone, is disabled. By the way, you can do the same thing with your laptop. It's just much more faster than me booting another laptop middle of the night. All I do is kind of put it on. I have already connected to SecurityTube previously, so if you notice on my iPhone, the connection to SecurityTube has happened, right? Let's get back to the packet trace. Let's stop the packet trace collection, and let's kind of quickly scroll up, and we are actually seeing a lot of data and traffic. So one of the interesting things is, kind of put a filter here and tell you why in a minute. What we also require is the broadcast address. So now let's go ahead and add two addresses. Right? And the other address is actually going to be of the iPhone client. So let me quickly add this address as well. And selected, and this should give me a whole bunch of details now, and these are all the packets going back and forth between the access point and the client. Right? Now let's try and understand this entire flow a little bit better. Before we do that, let's now change the filter once again and just allow the client filter to be there. This way we can see all packets originating or destined to the client. Right? This gives us a lot of more data, and one of the important ones is actually the probe request packet as well. So let me run you through exactly what is happening. Now the moment I cannot switch on the Wi-Fi interface on the phone or any laptop, the wireless client, or the STA as they call it, quickly starts searching the network to see if any access points are available. Now typically this is done by sending out what is called a probe request packet. So this is an example of a probe request packet. The wireless client sends this probe request packet to the broadcast address, and let me kind of show you how this packet looks like. When you see a probe request packet, the most important thing is the one we are looking at is actually a null probe request. What this means is the client is actually broadcasting and telling all the access points, well, I'm a new client here, can you please respond and tell me your SSID? And if you notice, immediately we get two responses. The first response is from our access point SecurityTube, which we've set up for our lab purposes, and the other response seems to be from another SSID Vivek, which I've kind of also set up. So actually in wireless, the client might go through various channels, keep hopping, keep sending multiple of these probe requests and probe responses. Now the client can send a probe request to a broadcast address, or it can specifically even send a probe request for a specific SSID. In this case, it's all broadcasts, right? Now let's kind of scroll down. What typically happens is that at some point the client receives a probe response, like in this case. If you notice, the client is also sending probe requests for other networks like wireless lab, etc. Let's not worry about that right now. These are actually networks which are cached in the client, and what the client may have connected to previously. Anyway, so SecurityTube access point, which is a D-Link access point, responds to the probe request with a probe response. Now from this point on, let's just concentrate more on the access point and the client exchange, and let's go ahead and remove all the other data. So let me just add the access point address as well. and wlan.sa actually means source address. Well, we'll just remove it and put it wlan.addr, which means this address can appear either in the source or in the destination or even in the BSSID. Okay, so two probe responses from the access point for the probe requests which we saw previously. Then if you notice, basically an authentication packet is actually going from the client to the access point. This, as you would know, is basically an authentication request packet, right? And basically we are using open authentication, which means actually there is no authentication, and the access point responds back with actually a successful code. So if you quickly notice at both these packets, the sequence authentication sequence number of the first packet sent by the client to the access point is actually sequence number 1, and the response from the access point to the client contains the sequence number 2. It's kind of zoom here. If you notice, this is sequence number 2. Now in later videos, when we will use shared authentication, you would see a lot many more packets involved in the authentication phase. Anyway, after authentication comes the association phase. Association is actually when, well, the client and AP are now satisfied by the credentials provided by the client to the AP, and the access point says, well, you've authenticated successfully, now let's associate so that we can start exchanging data. So when the client receives a authentication success response from the access point, it will actually send a authentication request, an association request to the access point, right? And in that, it would go ahead and actually specify a couple of things. Let's not worry about what these intricate things are at this point. And if the access point is satisfied with the authentication phase, it would go ahead and respond back with a association response with a lot of details such as what capabilities it has and things like that, right? Basically, once this receives this, after that data transaction starts between the access point and the client, and this is what we can see. The packet we are looking at is an ARP request packet for 192.168.0.1, and basically, as we can clearly notice, this is an ARP request packet to which the gateway responds with the MAC address, and after that we have a lot many more other packets. Anyway, so let's not worry about what comes next, we'll talk about that later. Okay, so let me quickly summarize what we've seen. We switched on our wireless client, which was our phone in this case. The moment we switched it on, we saw a lot of probe request packets going from the phone on the network. We saw two different kinds of probe request packets. One was broadcast packet, in which the client was basically just telling everybody, all the access points around, that hey, I am here, can you please tell me which networks are available? Now to this probe, null probe request as they call it, all access points which have been configured to broadcast their SSIDs immediately go ahead and reply saying, well, I am Vivek, I am Wireless Lab, I am SecurityTube, and I am available, right? The other kind of probe request is a directed one in which the client queries for a specific access point. Typically this happens when someone, which is the owner of the client, may have configured this access point onto the client. We saw that for a specific SSID Wireless Lab. Now after the probe requests, basically the access points send the probe responses. Now depending on maybe some user action, as in this case I had already configured to connect to SecurityTube, so there was an auto connect, or a user may see the list of access points and SSIDs available and select one from the list, as you may remember in Windows and other operating systems. Once that happens, the client sends a authentication request packet to the access point. depending on the authentication schema, if it is successful, then it gets a authentication response of success from the access point, right? After that, the client goes ahead and sends a association request, which is basically they're actually getting ready to really start talking to each other. Now the access point now sends back a authentication response back to the client. You can figure out who's speaking to whom just by looking at the source and destination MAC addresses, right? D-Link is my access point and Apple with the rest is actually my client. After that, data transfer starts between the client and the access point. So this is how a connection is created between a client and an access point, right? Okay, so now let's go back to our slides. So let's quickly summarize what we just saw. The client, which is the STA, as it is kind of called in the IEEE standard, sends out a probe request. Now the STA, the access point, sends a probe response to this, containing all its capabilities, security parameters, and so on and so forth. Depending on the security parameters, whether it is open authentication or shared authentication, etc., the client makes an authentication request. In this case, it made an open authentication request. The access point responds to that typically with a success if there is open authentication. Later we will see for shared key authentication, it responds back with a challenge. Anyway, let's keep it simple now. Auth request, auth response. Then the client sends out an association request. The access point replies back with an association response. Post that, data transfer happens. Now, other cases which we will look at later, we'll talk about .1x as well, but let's not worry about it for the time being. So this brings us to a very, very interesting discussion on state machines in wireless. Now, if you notice, the client and access point were actually going from one state to the other. Now, in the beginning, when, well, there was just probe requests kind of going out, they were unauthenticated and unassociated, right? The first step after discovery using probe requests and probe responses was authentication. Now, if a successful authentication happens, then they go to state 2, which is authenticated but still unassociated. From here, the association request and association response happens. If it succeeds, then they go to state 3, which is authenticated and associated. After this stage, data transfer can happen. Now, there can be a lot of transitions happening between these states. As an example, if authentication does not succeed, then we are always in state 1. Now, if authentication has succeeded, but we are unassociated for whatever reason, then we are kind of jailed in state 2, right? Now, when we are in state 3, which is we are authenticated and associated, at that time, if a disassociation packet is sent, then we go back to state 2. We'll come to what a disassociation packet is, etc. in later videos. And from state 2, if we receive a deauthentication notification, which means authentication is kind of chopped off, basically, then we go back to state 1. There is one possibility that from state 3, if any party receives a deauthentication packet, then immediately we go back to state 1, right? So this is how the state machine for Wi-Fi actually works. Keep this in mind. And one of the other important things is that the entire authentication and association, the probe request and the probe response, were all management packets which are being used to create a connection, right? Okay, this brings us to the end of part 4. Hopefully you enjoyed this video and I've been able to keep up my voice and enthusiasm even though it's pretty late here. I enjoy reading your comments. I really look forward to them. So if you've kind of seen till the end of the video, then please spend a minute to leave a comment behind. Well, that's all from my side. Have a great day ahead. Bye-bye. And open up my backtrack instance. Let me jump into full screen. And here we are. Right, so we've already connected the cart and created the monitor mode interface. So I request you to do that if you've not already done so. And what we'll do is, let's just launch Wireshark. Right, while this is happening, kind of ensuring that my access point is. Hey SecurityTube, welcome to part 4 of the wireless security mega primer. So before we begin, just excuse my pretty informal looks. I am terrible need of a haircut, and I'm looking quite tired because it's quite late in the night here in India. But I'm all what do I say, enthusiastic about making this video. So hope you'll enjoy it. Okay, so what is going to be the objective of this video? Encryption, no nothing. That's simply because let's start with a very simple case and then kind of move up the ladder. So what we are going to do is I'm just going to use my iPhone and connect it to the access point. And while this is happening, we're going to collect packets using Wireshark to see what transaction is happening between the client and the access point. Okay, so let's begin. Let me go ahead. Well, till now we've talked about the access point and the beacon frames and what they are. Now let's take it one level up and actually talk about the wireless clients and the access points talking to each other. And this is what we are going to try and strip down to the packet level using Wireshark. Okay, so demo time. Now what we've done is we've already created an access point with the SSID SecurityTube, and it's an open access point, no up and running. And also that my Wi-Fi on my iPhone is currently switched off. Right, as you can clearly see. Probably dim it a little bit. Okay, so now let us start our sniffing exercise. We're going to be on Mon 0. Before we begin this, let's go